Good morning to one and all person here. I am Ramesh, Assistant Professor in the Department of Electronic Communication Engineering, Excel Engineering College, Tamil Nadu. I am going to present the traffic channel allocation concept in wireless network. So first of all, I will introduce what is my channel allocation. So channel allocation is nothing but the total number of available channels it is allocated to one particular base station. Means it covers how a base station should assign traffic channels to the MS, that is a mobile station. Okay, so the number of channels allocated to one particular cell, it will depend upon the frequency reuse factor. So the total radio spectrum can be divided into number of channels. Means so the number of channels will depend upon the bandwidth. So for in case of FDMA or TDMA or CDMA, the total 25 MHz bandwidth divided into number of channels. So the number of channels it will depend upon FDMA, TDMA, and then CDMA concepts. That concepts we will discuss later. So the total channels, that is S, is equal to, so the number of channels is allocated to each cell is equal to S total divided by N. So the N is nothing but frequency reuse factor. So the frequency reuse factor is nothing but the number of cells it will share to the total channels. So the total the channel allocation scheme is very very important. So during the conversation here, channel allocation scheme can be divided into generally static versus and dynamic. So first it is a fixed channel allocation, dynamic channel allocation, and hybrid channel allocation. We will discuss one by one how the particular channel is allocated to the user. So first of all, we will discuss the fixed channel allocation. In that fixed channel allocation, the channels, the total number of channels allocated to one particular channel is permanent. It is a constant one. Okay, so the number of available channels configuration S is divided into sets. The minimum number of channels set N is required. So we can follow the rules of frequency use distance D. Once if we can follow the frequency use distance, we can reduce the interference. We can reduce the adjacent channel interference. So we can effectively maintain the distance. Okay, so within a cluster only they effectively allocate the channels, allocate the total number of channels. So here the green numbers A11, A12, the total number of available channels is splitted into each channels, that is A11 is 1 to 20, the A12 21 to 40. So the 20 channels allocated to each cells. So in the cluster size it will vary. Suppose the here in the cluster size is 7, the number of channels is allocated to 20. Suppose the cluster size is reduced to 4, so the number of channels allocated to one particular cell is it will be increased, it will be 30 or 40. So the cluster size reduced means the number of channels allocated to particular cell increase. So there is the main concept here. In case of fixed channel, the channels allocated to all the cells are permanent. So this is the main concept of fixed channel allocation. Some simple borrowing schemes also available. So there is SB means nothing but simple borrowing means accept a cell. Suppose on a particular cell all the channels are used, all the channels are currently using there, so there is no free channels available. In that situation, any one of the mobile station wants to communicate, wants to transfer their information. So at that situation, the one particular base station can having there is no free channels. In that situation, a particular base station wants to borrow some channels from the neighboring cell. So that is the donor cell. So here they are clearly explained. So NAME channels can borrow free channels from its neighbor cell, that is donor cell, to accommodate new calls. So here they are following some schemes borrowing from the richest. So some nearest cells having more number of free channels, so that type of donors will call as riches. Also we can follow some basic algorithms. Once if we can use the neighbor cells, and you can return back to the borrowed cell. Once if you use that channel, you can return back. So this kind of procedures we are following is a simple borrowing technique. So this diagram, it will clearly demonstrate. So here is one cluster. So each cluster there is, you have cell 1 and cell 2. This is cell 3. This is sectored cell here, like taking 3 sector x, y, z. So suppose a call initiated into sector x of cell 3 can borrow a channel from adjacent cells 1 and 2. I means these two cells only, they don't also, they are having free channel. This is the simple borrowing scheme. So this is one some complex channel borrowing scheme. So here in the complex channel borrowing means basically the frequency, the same cluster, the borrowing channel borrowing is more easy. So the interference is very less. Suppose some complex channel borrowing, you can borrow channels from the other cluster, nearest cluster. Here they clearly explain this x borrows some channels from a cluster. So in that some complex, here the main problem we are following the fact is interference. So can effectively borrowing channels from the neighbors. It is very very important one to minimize the interference. So there is the table wise scheme and displacing. This is simple borrowing, and then borrow from the rich. You can follow some basic algorithms. This is the simple table wise example. So another very good channel allocation scheme is dynamic channel allocation. So it is very efficient one compared to fixed channel assignment for some of the situations. So in that DCA schemes, all channels are kept in central pole. So here there is no separately allocated channel to each cells. So the total available channel is allocated to central pole. Whenever the call is request, the base station, the mobile station wants to request a call, the base station has to inform to the central pole, and can take it as central pole, say MSC. Okay, there is one simple example. So the base station initiate a call request to MSC. So the central pole will allocate the channels to one particular base station. Okay. So after a call is completed, particular channel is written to the central pole. This is also very important. So select the most appropriate channel for any call based on current allocation, current traffic. Okay, the channel allocation will depend upon the current traffic with the aim of minimizing the interference. So here also we go for dynamic channel version, you can minimize the interference. So this is the channel classification of dynamic channel allocation. Here are following. That is, centralized DCA schemes can theoretically provide best performance when compared to the fixed channel allocation. Provide useful benchmark to compare practical decentralized. Okay. So the distributed DCA scheme involves the number of controllers. Here, the controllers wanted to MSCs. Controllers want to continuously monitor the channel allocation schemes. So that is the scattered across the network. Okay. Assigns the traffic channels based on one of the three parameters. The core channel distance and signal strength measurements and signal to interference ratio. So these are the very big area. You can allocate the channels to one particular base station. The call is request. Okay. So this is some the comparison between a fixed channel allocation and dynamic channel allocation. Performs better under heavy traffic. So performance better under light and moderate traffic. Here flexible channel allocation a low flexibility in channel allocation. Okay, so low flexibility, high flexibility. So these are the, so the third one, other channel allocation schemes also available. That is hybrid channel allocation, flexible and handoff channel allocation. So in that hybrid channel allocation, you can combine the fixed channel allocation and the dynamic channel allocation. The total number of channels available for service is divided into fixed and dynamic. Already we have discussed. So in case of fixed channel allocation, the number of channels allocated to one particular cell is fixed, permanent. Whenever one particular cell can having, so all the channels are used one particular channel. In that situation, we can go for a dynamic channel allocation. Okay, so the base station, all the channels are used. In this situation, the base station can request to central pole, it require for some additional channels to establish a connection. Okay, so minimize the traffic. Here they are following some ratio of here optimal ratio of number of fixed and dynamic channels is 3:1. Fixed to dynamic provides the better service than fixed when traffic load is, so when the traffic load is less, means it is traffic less than 50%. So beyond 50% fixed scheme is for better, perform better. Okay, for dynamic with the traffic load of 50% to 30%, better results are found in SCA. Once the traffic is very high, means the channel allocation scheme also very difficult in case of dynamic channel allocation scheme. So in that situation, for a heavy traffic situation, the fixed channel element is somewhat less problem, following the less problem. So here some of the is the reuse pattern. It is each cell is divided into equal size zones. Okay, so and then overlapping cells, it is a one is a arrow mark is hexagon shape, is a macro cell. It is these are inner cells are micro cells. The micro cells come mainly for a low traffic, that is a low mobility devices. The MS with low mobility are assigned in micro and pico cells. High moving MSs are assigned from the big cell, that is the macro cell. Sometimes the mobile terminals is to moving at a heavy speed. Suppose we want to travel in a vehicle, in this situation you can use the mobile phone. So the connectivity it will be based on macro cell. Suppose for see mobile phone while you are walking, so the mobility is very less. In this situation you go for micro cell concepts. Okay, this is another big concept. So there is next one, overlap cells. So the use of overlap. Suppose here three A and C, it is overlap, and B and A also it is overlap. Suppose A, you are in A cell. Suppose if you want to move to B or C, the handoff is very very important. Suppose if you are not having enough channels available in channel A, so in that situation you can get channels from C or B. Okay, that's when they clearly explain. So if a new call in a cell A cannot find a free channel, so some of existing connections in a shared area of cell A will forced to hand off to cell B or C. Okay, these are the concepts available in channel allocation schemes. So thank you for giving the great opportunity to explain the traffic channel allocation wireless networks. Thanks to IIT Bombay to giving me the great opportunity to explain my ideas. Thank you once again.